marketing manager. Brad's kind of doing the future product kind of looks of where we're going with products, although he's not going to tell you anything future. Whereas Kate's managing current products and kind of the marketing aspect of the product. So Brad's he's a marketing kind of defined as a marketing guy because he reports in marketing, but he knows the product probably better than anybody around here. So.
All right,
Take it away.
thanks, Calvin, and thanks for ratting me out as a marketing guy. I wasn't going to mention anything about it. Just to prove that I'm not your typical marketing guy, I'm going to try and do this whole thing without any slides today. So,
Hear an applause.
Calvin suggested that I attempt to do it that way, and so we'll see how it goes.
Nothing like working without a net.
So to make it even further without a net, we wanted to talk a little bit about our P4800 product today. Craig mentioned it briefly in his presentation. We were hoping to get a rack for you guys to actually look at the hardware here today. We weren't able to get one in the room in time, so what we are going to do is we're going to do a walkthrough of the lab later, and you guys will get to take a look at the actual hardware that we have for the P4800 and some of the other left-hand products as well. In the meantime today, we'll just have to kind of use our imaginations. I'll do my best to maybe try and squiggle some stuff up here on the board if that might help us visualize some of the things. But I want to keep this open. I encourage you guys to ask any questions along the way. Stop me if we need to delve deeper into anything that I'm covering. And I'm going to try and jump around a little bit, cover a few different areas about the left-hand product. Again, fortunately, I can't get too far into some of the really exciting things that we've got coming up just around the corner, but I trust you'll be hearing about some of those things in short order. So stay tuned for some of that stuff coming down the road. I guess what I'd really like to try and focus on is to try and tie in some of the concepts that Craig was talking about in terms of the vision of HP storage. Where are we going? Where do we see the market going? And then get a little more detail into how that translates into some of the stuff that's going on with the left-hand product line. So I think, Calvin had taken an impromptu poll of the audience here today and reported back to us on your familiarity with the various product lines, and it looked to me like there was a pretty good level of familiarity with the left-hand product line among this group. So just to confirm or deny my assumption before I dive in too deep here, just by a show of hands, if you think you have, a moderate or higher level of understanding of left-hand, can I just get a quick show of hands? So, all right, about half the room then. So I'll spend a little bit of time just talking at a high level about the solution. Basically, market-wise, we're positioned as kind of a mid-range solution. We have a wide portfolio, so we can go very much down into the entry space, the remote office space, right? Craig talked about our VSA product. I want to talk about that a little bit. High end of our portfolio is that blade-based product, the 4800, right? And we can really get pretty high up into the mid-range, even low enterprise range with that product. So it's a broad portfolio. We cover a big segment of the market, but without a doubt, our sweet spot is right there in the mid-range. Virtualization plays #1 use case in our customer base. So when you're talking about left-hand, that's really the market that you're thinking of. That's the market that I'm thinking of when we're looking at our roadmap, when we're looking at our product development. Those are the customers that we're trying to march in lockstep with. Again, core philosophy, it's a scale-out architecture. Basic concept is we build storage clusters out of storage nodes, right? And a storage node can be any number of things. It can be a rack mount server, it can be a blade-based platform, it can be a virtual machine. But you build clusters out of these nodes, and then you can combine these clusters into what we call management groups. And that's where the concept of storage federation comes in when you start talking about left-hand, right? We have all different speeds and feeds and shapes and sizes of left-hand platforms. They're all appropriate for different types of use cases, different levels of performance. You have the ability to build different clusters and think of a cluster as a set of disks that you're dedicating to a set of applications or one application, or however you want to slice and dice it. But within a cluster, we'll stripe all that data across all those disks, and you've got a predictable level of performance based on how many nodes you have in that cluster, what type of disk they are. And then you can create different clusters to serve different requirements for your sets of applications. Where federation comes into play there is within any of these clusters that you've built, you have the ability to migrate data online using the pure motion technology for left-hand. So in the left-hand model, this is literally a couple clicks in our UI, right? You go into your volume, under the details, there's a cluster ownership tab, and if you have more than one cluster in your group, you can drop down that list. It'll show you all your available clusters, and if you want to move it, you say, move me to my SAS cluster, move me to my, capacity cluster, move it to my VSA cluster. And the system will go, it'll redistribute the data onto the new cluster, we'll rebalance the iSCSI session so that your host is pointing directly to a node on the new cluster, and it's all done seamlessly in the background. The user has a control mechanism to dictate how much bandwidth is allocated to the restripe activity, so you have the ability to make this go faster and take a little more of the system resources, or go much slower, have it be imperceptible to the users and take a little bit longer. And you can move that back and forth. You can turn it up at night, turn it down when you get in the morning, crank it up over a weekend. So for all the pure motion activities where we're redistributing data kind of behind the scenes, we still give the administrator control to dictate the speed of that and the impact that it has on overall system resource usage. So the online volume migration is a big part of our storage federation story. The other part of our pure motion story, like Craig mentioned, is the asset refresh piece. And so in a left-hand model, that's what we call our cluster swap technology. So if I built one of these clusters that I described to you, maybe it's 3 or 4 rack mount servers. I've had that thing in production for a number of years, and I decide it's time for me to refresh that resource and upgrade. I can bring in a new set of left-hand nodes. I bring them online, I rack them up, give them IP addresses, add them to my management group, and there's a cluster swap feature under the cluster menu. I say swap nodes, I select a new one, say get rid of them, I select the old one, say add them, I say go, and I'm done. I'm literally done. All iSCSI sessions are immediately migrated over. My virtual IP address, which is kind of my cluster interface for all my hosts, immediately migrates onto my new cluster. Again, the restripe activity is totally dictated by the administrator. When I'm done, I can take my old nodes out and I can use them for whatever purpose I want. I can set them up as a tier 2 storage cluster. I can relocate them, set them up as a DR site, use the remote copy feature within left hand. We have a lot of interoperability so that if these are older nodes running an older version, I still have the ability for them to do remote copy back and forth with a new set of nodes at my primary location. So interoperability between all the different platforms within the family is definitely a key part of our storage federation. Just to review in a little more detail what those platforms are, kind of at the low end, but it's not really fair to just position this as a low-end product as our VSA product. I'd like to actually talk a little bit about our VSA. That's a technology and kind of a philosophy that we're seeing gain a lot of traction in the market. So storage as a software, appliances that are based on virtual appliances that virtualize storage. There's a couple different flavors of this approach out there. I'm sure you guys know about the VMware product. There's some appliance-based solutions out there that are doing very much the same thing. Just by the way, in the interest of disclosure, I didn't give you much background, but I was actually a left-hand guy. Spent a few years with left-hand before I became part of HP, and was kind of part of the team that worked on the original VSA. So that was about, it was over 4 years ago that we launched the first VSA from left-hand. So left-hand very much a pioneer in the technology of virtualized storage appliance. It was the first one out there, and we've had years to improve and hone that product. So we have some real strong advantages in our approach to that. It really is a true virtualized SAN, whereas there's some other products out there that kind of want you to use their product instead of having to buy a SAN. We really look at ours as a virtual SAN, so you get all that functionality that you expect from a SAN in a virtual appliance, and I think that's a pretty important distinction. So we have our VSA, then we move up to our rack mount models. Right today we've got what we call 4300, 4500. Those are available in a couple different disk speeds and sizes. We've got 7200 RPM midline SAS, we've got 15K enterprise SAS, and then we move up to our high-end platform, which is the 4800. That's a very unique product. It's the only blade-based SAN in the industry. It's fully integrated into the C7000 chassis. There's a lot of unique functionality that you get out of that form factor by having your SAN in the same chassis as your hypervisor blades or your application servers. It is absolutely the poster child for converged storage and converged infrastructure. So let's talk a little bit about that. But diving into a little more detail on some of these particular platforms, let me talk a little bit about the VSA first. And for me, the VSA really adds, as Craig says, on the one hand, it's very much, a picture of convergence in that you'll have your storage running as a software inside a virtual appliance, inside your VSX or Microsoft server. So from that standpoint, it doesn't get more unsiloed than that, right? It's running right there inside the same metal as your applications are. So from that standpoint, it's a very elegant solution. The other thing where that really comes into converged storage and storage federation is I like to think of the VSA as a way that you can annex any number of third-party storage devices and add them to your left-hand federation. So that's pretty important. If I have a left-hand array in my data center, and we know about all the interoperability and pure motion functionality that we can get out of that. The ability to be able to add third-party storage, whether it's older fiber channel or iSCSI arrays. Craig used the example of maybe I have a couple SSD disks sitting in one of my servers, and I'd like to be able to share that storage out and make that performance available to other applications, right? With the VSA, I can take whether it's direct attached storage, whether it's internal inside of an ESX server, or whether it's an external array, iSCSI or fiber channel. I can put VSA down on there, and that array or direct attached storage is now part of my left-hand federation. So if I put that VSA down there, I can use remote copy back and forth to send snapshots for DR-type solutions. I can do pure motion to redistribute my data as my workloads change. And if I'm using VSA as kind of an entry platform, when my environment grows and it comes time to graduate to my physical platforms, I can use the pure motion cluster swap to upgrade from VSAs to physical platforms. So a lot of data mobility, a lot of flexibility, a lot of agility. Those are all kind of the values that we're looking for in the next generation of storage products. Virtualized infrastructure presents a lot of unique challenges, and people are looking for storage that allows them the flexibility to answer those needs. So that's really, in my mind, what the federation is all about, and this functionality that we've been driving into the left hand is really aimed at providing that ability to
So Brad,
administrators.
Can the other platforms support external storage, fiber channel, other devices out there? I mean, like the VSA. So VSA can support anybody's storage effectively. Mm-hmm. The other platforms do that as well?
So no, the other platforms are strictly appliances. So you're going to get, all your resources, your disk, your cache, your CPU, your memory, in one package, and then you build clusters out of those. So it's completely scale out, but it's scale out within the context of, the individual node form factor that you're working on. So we do not do anything in the way of scale up in terms of adding an external array to a left-hand device. It's pure 100% scale out.
Is there any plans, and this may be getting into futures, but for different types of disks other than the two they're currently offered? I'm thinking SSDs.
So I can say that there are plans, and I can't say any more than that, but just stay tuned because there will definitely be exciting news to come on that front. Any other questions right now before I blab away some more? Cool. So that kind of covers a little bit of where I see some of the prime use cases for the VSA.
So Brad, what's a VSA cluster look like? I mean, is it multiple servers connected together, or?
So it can be any number of things, and that's actually an important distinction between the way our clustering works with left-hand and some of the other solutions that are out there. A VSA is just left-hand running in a virtual machine, so the device itself has no knowledge of whether it's sharing a cluster with VSAs that are on the same host or different. It's completely oblivious to the host that's underneath it. So the most common implementation is a single VSA per host, and then you cluster those together. But our licensing works on a 10 terabyte per VSA limit. So if you've got hosts with more than 10 terabytes of raw storage, you absolutely can put down more than one VSA on a host and still build clusters. Now, that's where you have to start to think about your availability equation, right? If I have 3 VSAs on a host, right, and that host goes down, you know, my replication across VSAs isn't going to help me, right? So you have to think about that sort of thing. The other thing that's important is when we cluster VSAs, we use the same algorithm for striping data across nodes in the cluster that we use with all our other devices in SANIQ. SANIQ, by the way, is, just in case you don't know the term, that's the software stack that runs on left hand. That is actually my kind of main area of focus as a product manager. I own the SANIQ roadmap, so that's really what I spend my time day in and day out working on. So it's an important distinction that with SANIQ, anytime you build a storage cluster out of nodes, whatever kind of node that is, if it's a VSA, a blade, or anything in between, all the data for every volume is striped across all of the disks on all the nodes in that cluster, and that's true for a VSA too. So if I take 3 ESX servers and I put a VSA down on, you know, the majority of the disk that's available in each of those servers, and I create a volume, all the data that's written in that volume is going to be shared across all those host servers, right? And that means that if I've got 12 internal disks per server, I've now got 36 spindles supporting that data, right? So some other VSA solutions out there have an active copy of a volume on one host and then a backup copy of the volume on another host. And that means that no matter how many VSAs I can put in that cluster, I'm only getting one host worth of spindles behind that data. So the performance capability of the system has got a pretty hard ceiling on it, and that ceiling is the amount of disks that you have in one host, right? VSAs work exactly the same as our physical nodes, meaning that as I build out a cluster, and we'll scale best practices up to 10 VSAs, you can actually go larger than that. We recommend keeping it to 10 within a cluster. You can build some pretty big clusters with our VSA, and you will see the same linear performance scalability that you see with all of our.
So Brad, can you cluster together VSAs and some of the other platforms, or they all have to be this homogeneous platform?
So from a practical standpoint, they should be homogeneous.
Okay.
So there's nothing in the software that will stop you from adding a node of a different type into a cluster. The thing that you have to think about is a left-hand cluster functions as every node being homogeneous and kind of interchangeable. So from a capacity standpoint, right, because we stripe the data evenly across, and because we have to be able to function with any one of those nodes going down at any given time, right? We haven't talked too much about network RAID, but that's the replication mechanism that we use to stripe multiple copies of data, or sometimes it's data in parity, but basically to protect your data. So we treat nodes within a cluster very much like disks within a RAID set. And using those same principles, we allow you to actually lose an entire node in the cluster and still have data access, right? Whether it's network RAID 10, which is like a disk mirror, or whether it's network RAID 5, which uses parity to be a little more space efficient. If you lose a node in a left-hand cluster, you're still up and running. That's different from some of the other cluster distributed storage solutions that are out there, where even if they have dual controllers, if an actual node goes down due to a different kind of failure, that data is no longer available. Network RAID protects us against that type of failure. But that also means that every node has to be expendable. So if I have more data on this node than this node, and I lose this node, then I don't have the ability to have that data somewhere else. So for that reason, if you have a larger node in a cluster with smaller nodes, the usable capacity is only going to be the lowest common denominator. The same more or less holds true with performance, right? We stripe the data across all the nodes in a cluster, so I'm constantly accessing a disk here, a disk here, a disk here. The performance of the overall cluster is going to be as fast as the weakest link, because X% of my I/O access is going to be hitting, any disk in the cluster, right? So if I have a set of 7200 RPM disks in a cluster with 15K SAS, every time I hit that 7200 disk, I'm going to be waiting for it to finish before I can service my other request.
And so within a node, you support something like RAID 5 or something like that?
Yeah.
If you only have a single node cluster, for instance?
Correct, yeah. So there's a couple levels of protection within the system. Each individual node will have disk RAID on it, so you can do RAID 1, technically it's RAID 10, RAID 5, and RAID 6 within the node. So if you lose a disk in the node, you're not going to lose that whole node and have to rebuild the whole thing. Then we do the network RAID to protect you beyond the node level. And then network array actually allows us to do what we call our multi-site solution as well. And I want to make sure I cover that real quick. So that's where when you use our network array 10 technology, right, I've got a mirror of the data within a cluster, right? Presumably an even number of nodes if it's array 10. I can actually take one side of the mirror and put it in one physical location, one side of the mirror put it in another physical location. I've now taken my single cluster that might have been in one rack, stretched across 2 physical locations. This can be done not only across separate buildings, but people use this to create failure domains within individual racks. First floor, second floor within a building, different zones within a data center. If I've got different fire zones or power zones, you can use this, you can create your own failure domain. So people think of our multi-site as protection against site failure. If I have a power outage in my data center, I have a mirror in another data center with synchronous live replication, and that's definitely a killer use case, but a lot of people that don't actually have geographically separate sites still use multi-site to create failure domains so they know if somebody trips over a power cable here, I'm still up over here, or if this rack goes down, I'm still up in my other rack.
Can replicas both, can the source and the target of a replica both be accessed, read-writable?
Yeah, and it's a different model, so don't really think of it as source and target. So if we have any, the way that I like to kind of illustrate it is if you understand the way network array works, say these are 4 left-hand nodes in a cluster. When I start writing data to a left-hand cluster with network array 10, these are what we call pages of data. So we use a 256K page size, and as soon as I start writing with network array 10, the very first write that comes in is going to go to node 1 and 2. Second one's going to go to 2 and 3, 3 and 4, and then 4 back up to the top. And it just basically, the more nodes I have, it keeps that same algorithm, right? So this is what your data layout looks like. This might be a cluster in a single rack. And at any time, depending on what type of host operating system is, there's going to be rules for, one host is accessing the cluster via one node or maybe more than one node, depending on if I'm using multipathing and all that. But there's rules that govern that. And those rules are the same whether my cluster is in one rack or whether it's in 2 sites. So because I have this data laid out this way, right, my rules are I need to have A, B, C, and D available in order to access my data, right? So if I lose any one node, if I lose this guy, I've got A, B, C, and D. If I lose this guy, I've got A, B, C, and D. If I lose these 2, right, I don't have C anymore, so I'm down. And so just like an array 10 disk mirror, right, once I've lost one disk, my ability to survive a second failure depends on which disk that is that goes down. And it's the same thing with our nodes. And the way it works out with network RAID is that it's every other node, or you can think of it as odds or evens, right? So what that means is I can take 2 and 4 in this example, right? If I lose those 2, I still have A, B, C, and D. So I could literally, and we'll talk about managers and quorum, there's another requirement, but I can take 2 of these guys, I can shut them down, I could put them in my car, I could drive them across town, power them back up over here, and I've now got the exact same cluster running stretched. We've really taken one cluster and stretched it across 2 locations. So there's really not a source and a target. Every time I do a write, it may start off on one side, or it may, the initial write may go on the other side, but either way, it's going to get replicated to the other side and acknowledged back and then back to the host. So I'm not sure if that answers your question or if that just frames your question.
That's, of course, limited to synchronous distances, right?
Yeah, so there are definitely strict networking requirements for this. You need minimum of a gig, and we recommend 2 milliseconds or less round trip latency.
So in that case, both sites can access A, B, C, and D, and
Right.
be reading and writing to them, and they'll be synchronously replicated across
Right.
as
Now,
a need.
there's,
It's a true metro cluster.
yeah, absolutely. So there are, session management rules in place to make sure that, LUNs aren't being accessed, in 2 different places by a host unless the host operating system can handle that type of thing. So, we cover it from that sense, but yeah, there's not one active and, not a target and a source in a traditional sense. It's really one cluster stretched across 2.
Yeah, it's kind of interesting when you go to the to HP.com and go to the VM or the P4000 page and look at all the case studies. I'd say almost 3/4 of the case studies are P4000 and VMware, I'd say about half of those, if not more than half, are the customers deploying exactly this, and utilizing it with VMware HA.
Yeah,
To
absolutely.
set up the sort of scenario that Brad describes. Like because I was at Left Hand too in the early days, and when the VMware SEs kind of first understood this, they kind of called this the killer app with VMware, because you could set up these highly available metro clusters, and as you said,
Yeah.
and you could do it with a very affordable, simple to configure, simple to manage type thing. So they really loved it and latched onto it.
Yeah, and I think maybe when Craig was talking about some of our kind of walking in lockstep with VMware in our left-hand heritage, this was one of the things, and the VSA is the other thing that kind of comes to mind for me. But one of the things, I mean, this is just a perfect fit for VMware HA, and you can even run this with fault tolerance if your Link can support it. So it's just, you take the HA features in VMware and you combine them with the multi-site features in left-hand, and you just got a level of availability that's really unmatched. The other thing about this solution, the left-hand licensing model is all-inclusive. So all the software features within CNIQ, multi-site, remote copy, everything else, it's all part of the base license. So if a customer, is invested in left-hand and they decide down the road that they want to set up a second location, maybe they get a faster link put in, that technology is there for them to take advantage of right at the back. They don't have to go back and buy additional licenses or anything. Anything else on multi-site? Because that is really a big differentiator for us. Something we're continuing to invest in. And like Mike said, a lot of our customers have taken advantage of that over the years. Even if they don't have a second location, they'll still find ways to take advantage of it. All right, cool. Let me talk a little bit then. So we talked about the VSA.
Hey Brett, make sure everybody knows that we're going to actually do a VSA hands-on lab. I mean, it's on the agenda, so you've probably seen it. So for those of you that haven't had any hands-on with it, you're going to get it right after Brad's done.
So the next section here, we're going to do a little lab in the back. We're going to show you our new deployment tool that we released for VSA late last year. So I did want to talk a little bit about kind of the high end of our portfolio, and that's the P4800. The P4800, we've talked about a little bit. It's the only thing of its kind out there today, and it's a blade-based SAN. So if you understand kind of the concept of, the nodes I just built, I always draw rectangles when I'm diagramming left-hand clusters, because traditionally the rack mount server has been our kind of most common building block, but that building block can also be a blade-based platform. And in that area, we have a half-height blade. It's an ISS blade that's at the heart of that thing. And instead of a disk, we have a couple disks in here for our operating system, but all the user data is stored down here on a big fat JBOD, right? And we generally deploy these things and sorry, my artistic skills are severely lacking. We generally deploy these things in groups of 2, and the reason for that is the JBOD is an MDS 600. There's 70 disks in this thing. It's got 2 drawers. You'll see it in the lab when we walk through it in a little bit. If you haven't seen these things, every time I've been to a show and we demoed one of these things, like everyone's favorite thing in the world is to watch us pull out that shelf of drawers, and there's 35 flashing disks in there, and it's just such a big, dense chunk of storage and all those flashing lights. I don't know, people just get excited about it. So,
it's awesome.
But it really never fails. I mean, if you put a camera in our booth where we're demoing a 4800 and you just get the reaction shots of people when you pull out that drawer, it's always like the eyes get big every time, I swear. So it's actually really cool. So I mean, kind of your base building block for the 4800. It's a little different. The architecture works exactly the same, but from a practical standpoint, one JBOD serves 2 nodes. So you really build this thing out in sets of 2, right? And today we offer both 15K SAS and 7200 midline SAS. So we've got just recently we launched our capacity version of the 4800. So in that model, we've got 2 terabyte disks down here. So 70 disks, 2 terabytes, that's 140 terabytes raw of storage in a 2-node system. So if you've been familiar with kind of the left-hand product family and the normal kind of capacities and densities that we're talking about, both from a terabyte standpoint and from a spindle count standpoint, right? You know, even in the 2 terabyte models for the rack mounts, you're talking about, you know, you're talking about 2 terabytes times 12, what's that, 24 terabytes in a node and 12 spindles. For the 4800, we're talking about up to 70 terabytes in one node, so almost triple, and then of course triple the spindle count too, so 35 disks behind a single node.
Right, real quick, why the 2 terabytes when there are the 3 terabyte nearline SAS out as well?
So we, you know, continue to qualify drives as they become available. So we'll continue to, you know, ride that train. Right now we're at 2 terabytes.
Or in English, because we're a big company, it takes time.
So yeah, so I mean the densities that you can get out of this platform far beyond, you know, anything that you can get out of our more traditional rack mount models. So this solution was originally built and designed as a VDI solution. So that was kind of what we had in mind when we first, you know, were building the 4800. And there's a couple of advantages in a VDI use case that you really get out of this. And I want to talk about those. When we actually launched this product, it was about a year and a half ago, and we launched it under a very controlled policy. We basically said this is a VDI only product. So for the first couple quarters, if you wanted to buy a 4800, you had to get your order approved. You had to kind of you know, go through and explain that it was a VDI use case, and we wanted to make sure that this product had a successful launch and that it was targeted in appropriate use cases. And then after you know, close to 2 quarters, we had a bunch of successful installations in the field, and we kind of lifted the reins and we said, okay, go ahead and have at it. It's now general purpose SAN. You can use it for anything you want. But the original use case was VDI, and as far as general purpose, it's only been on the market for a year, and I just saw a mail, and I guess this is something I can tell you about in the futures area. That's not really very exciting. It's not a technology announcement, but we will be announcing that we just have sold our 1,000th P4800, and that's a pretty good uptake in the year that it's been available as a general purpose SAN. So we're seeing a lot of traction with the 4800. It's really starting to ramp now. We're getting large-scale deployments of it. We're getting multi-site deployments now, where people have C7000 in one site, C7000 in another, and they use that same technology. So it's really starting to take off. Something we're really excited about in our portfolio. So a little more about what's in here, right? I've got my blades and I've got my disc down here. That's kind of the heart of the solution, right? I've got inside my, you know, my rack here, I'm going to have some SAS switches, redundant SAS switches, right? That'll connect my blades to the storage, and then I'm going to have Flex 10 or Flex Fabric modules, right, to handle the network piece of it. And so what's cool about this is that in a single enclosure, right, I've got my compute. Right, so actually, I've got this is a C7000. Let me move these guys. Got my C7000. I'm not going to draw 16 boxes here, but you know how it goes, right? I've got whatever it is. So I'm going to have, the way it works is some segment of the right side of my chassis is going to be my storage blades, right? And those are going to connect down here to my storage down here. On the other side, you know, the left half or possibly more is going to be my compute, right? So in a VDI environment, these are going to be my VMware servers or my Citrix Zen servers, right? So in this box, I've got my compute over here, I've got my storage over here, I've got my networking here. So, I mean, when we talk about converged infrastructure, right? Servers, storage, networking, it's all in one package for you in this product. And besides being kind of conceptually cool, right, there are definite advantages to this. So first of all, if this is a VDI deployment, these are my VMware servers. When my hypervisor is talking to my storage, right, it's not going out over a network, whether it's Fibre Channel or iSCSI, out through some switches, off to my storage, back across the network, right? It's going across the backplane of the C7000, which is extremely fast, extremely low latency.
It's going through the switch in the back of the C7000.
Sorry?
It's going through the switch in the back of the C7000.
Right, but that's a lot lower latency than traditional network going out and back again. So the other advantage there is, right, I don't need that physical hardware sitting out here if it's 2 or 4 switches, you know, bundles of cables. going out between every server and everything. So I mean, we used to have a slide. I know we're not. I can talk about slides. I just can't show them. We used to have a slide of a shopping cart full of switches and cables and hardware that you save by having all this stuff in the same enclosure, right? So just from obviously, you know, you can deploy very performant solutions with fiber channel iSCSI switches. I'm not disputing that. You know, just even from a management standpoint and from an investment standpoint, from an infrastructure, a model like this where it's all in one enclosure, we think is very attractive.
Where does the management is the management software run on one of the storage nodes? Is it run on compute
So
nodes?
the management software for left hand is what we call our centralized management console. So you can have that outside. You can have a management blade in there if you choose to. A lot of people will run Virtual Center and CMC on one management blade. Some people are cavalier and they run it in a virtual machine, right? And they count on that. Personally, I think running Virtual Center on virtual machines, you know, a little bit sketchy. I've seen people do it though. So that can really run anywhere. Our management console runs, you know, on pretty much most flavors of Linux and Windows. The onboard administrator software for the blade system can also be used to manage like your profiles, whether you're managing your storage or your compute blades. So that's kind of an overview of what the P4800 looks like.
One thing to mention is our support for Flex Fabric.
Yeah. So this was originally Flex 10 only, and late last year we announced support for Flex Fabric as well. So for customers, another change. So we've continued to kind of you know, broaden the ways and the use cases that you can do with this. Originally it was a lockdown config. It also used to be factory integrated only. What we've now allowed you to do is field integrate this. So customer has an existing C7000 chassis. They can bring in 4800 and install it in their existing chassis. And so if they've got a Flex Fabric module already in there, they can go ahead and use that with a 4800, where initially we had a Flex 10 only. So we're trying to, you know, broaden the options for integration with this thing as much as possible. And we do have some, you know, next generation plans for this that are very exciting that I'm not going to tell you about.
As far as the disk shelf itself goes, can you speak to any features as to other solutions that might be a part of? I'm thinking of just, you know, just a simple JBOD that you could attach to a DL380 or something.
Again, can't get into roadmap details. I can tell you that there are plans for several additional JBOD options that will be coming into the portfolio when we kind of refresh our hardware family. So without going into detail, generally, yes.
Because I think that disk shelf is a sweet solution. And there's so many different solutions I think of that would be a good use case for.
Yeah, so we think there's all kinds of possibilities that you can do with this thing, and we've got a couple in mind that we're targeting for next generation. So there's definitely, I mean, the MDS is sweet, but it's, you know, your building block is 70 disks, so that does sort of, you know, limit you in some ways. So we'd like to offer.
We're thinking more like we like that high density. We want to use it for something else.
I mean, think of it as a shelf for an EVA. I mean, oh my gosh.
Yeah. So the MDS 600, I mean, we see that deployed in other use cases as well. So one common use case on that one is direct attached storage for Exchange 2010. You see that a lot.
Are they running on the G7s?
It's G7's blades in here, yes. Anything else on the 4800 or general questions at all? All right, cool.
So when you cluster together P4800s, they could be across different blade servers. They could be, you know, so you could have, for instance, a couple of blade cabinets there, and they could all be clustered together, and you could stripe the data across all of them. Is that?
Yeah. So I mean, there are, you know, some practical limits to what we recommend in terms of scalability. Probably the biggest that you would want to look at for this kind of thing. So in the C7000, because of the SAS fabric and everything, you can go up to 8 P4800 blades in a single C7000, right? One thing that we've got people doing now is putting a C7000 in one site and then creating a nice big fat uplink pipe out and then having that run out to another site over a high-speed network and then having another C7000 in the other site. So you can go, our best practice kind of ceiling for nodes within a cluster is 16. So if you got 8 over there and 8 over here, you're pretty much at the limit of where we say, you may start to run into scalability issues if you go too much bigger than that.
Would you see any advantages to clustering together 2 separate blade systems, I mean, within a local site without the multi-site?
So if you wanted to create a failure domain, either for, on an enclosure level, you might consider doing that. If you decided that you wanted to be able to survive the loss of any one enclosure, and we do have customers that are doing this. We have customers putting one enclosure in one rack and one in another rack and striping a mirror between them. So if you set the nodes up in the right order, then you've now got redundant racks of blade-based storage sitting right next to each other. And as long as you've got that pipe configured properly and you've got lots of bandwidth available to you there with Virtual Connect, then you should have no problem doing that.
What's the capacity limitation on SandIQ per cluster?
So we don't have a capacity limit, and SandIQ will let you build clusters as big as you want. So we've done lab tests with clusters as big as 30 nodes, right? There are in the product, if you look in the management console, there's what's called a configuration summary and a best practice analyzer, and it will tell you if you're running afoul of any of our best practices. So 16 nodes is our ceiling before you get into the danger zone on cluster size. So that's 16 nodes of any size or shape. So if you take 16 of these big guys, then that would be your biggest that you could build and still be within best practices.
I don't remember exactly the number, but I remember having a conversation with a certain VMware engineer in the Netherlands who told me he had helped put one out there. And I think he said it was like close to 30 nodes, and it was like, oh my gosh, you gotta be kidding me, a 30 node cluster out there? Wow.
Yeah, so we have customers that have pushed those limits, and we've done it ourselves. We're trying to provide general guidelines of sanity, and it all, there's a lot of variables that go into, it's not like if you've got 16 nodes in a cluster and you add another one, the whole thing's going to grind to a halt, right? I've worked with customers personally that run 20 node clusters and they're fine. I've also, I used to work in tech support, so I've talked to customers that had 24 node clusters and things weren't going so well, and we split it in half and they ran a lot better. So, we've done a lot of testing within our our engineering team to try and guide customers to some practical limitations, and some customers have a lot of experience with the product and have found that for their environment they can push those limits in certain areas. Any other left-hand questions right now? I think I've been going about 42 minutes.
Is there any, does Network Grade 5 still use snapshots to?
Yeah, Network Grade 5 does still use snapshots. We changed that in SandIQ 9 so that it doesn't use snapshot schedules anymore. So when we first introduced the feature, when you converted a volume or created a volume in Network Grade 5, it would give you a default snapshot schedule, which you could alter if you wanted to, and it would show up as a snapshot schedule. And so you would only generally encode once a day. So whatever data you, so in order to get adequate performance with Network Grade 5, what we've done is we found that encoding parity on the fly was extremely expensive. It had a pretty big effect on performance. So we create kind of a top layer that's Network Grade 10, where we don't have to encode parity, and then we encode behind the scenes with snapshots. So starting with SandIQ 9, we're now at SandIQ 9.5. Rather than do that on a time-based schedule, we treat it a little more like a cache. So whenever that top layer fills up with either 10 gigs of data or 10% of the size of the volume, we'll kick that down into a snapshot and we'll encode it. So it's a little more efficient. You don't get as many big chunks of data sitting in your top level, and then if the schedule fires, you may have a lot of work to do all at once, where we could have been chipping away at that more incrementally.
That's why I asked. We have a customer that does remote snapshots to a DR site, local snapshots, and they ran RAID 5 volumes. And we'd start to see the storage system say that they were working basically, and then everything would just get behind and performance.
This
would
was with the scheduled.
They were on 9.5, they still are.
Yeah, so it is chipping off. I mean, it may be that if they're writing very aggressively to the volume, the system can fall behind, and that volume's probably not a great candidate for network grade 5. So we do, put some guidance in the UI towards suggesting what are the appropriate use cases for that, because it's definitely not for every use case.
They were just trying to save storage. I mean, we moved them back to RAID 10 and it works fine then.